Welcome back, ladies and gentlemen, to the second or better third part of our trading series. And right now I'm going to show you which data to choose. Well, we have seen already how to use the send to AI UI script. Okay, you drag and drop it onto the chart you want to use or the market you want to use. And what we haven't talked about is like you can give it a name, right? In this case, usually I would say we have chosen the S&P 500, so I call it S&P 500, right? It's a 1 hour chart, and in this case I have chosen like 30, 10, and 20 as min-win pips, max loss pips, and prognose horizon. Also, I have changed some of the indicators because we found out the Nyquist moving averages might not be programmed properly. So use these with caution. Maybe you can check it and find out what's wrong with it. So in the further trading videos, we will just use these indicators. If you now click on OK and have a look at the journal, right, you will see information. You will see when the script is done. You can see here it is removed now. That means it's over. And if you got more data points, it will take a little bit longer, like for 200,000 points. That would be like 3 years of data, of 5-minute data. Then it might take several minutes, like 5 minutes or so. Then you will see not a loading screen, but it will give out, okay, 10% done, 20% done, and so on. And we also added some labeling into the chart. That means based on what you have chosen here, right, there are specific trading labels set as described in the first video, in the introduction video, and now it's visualized. Okay, you see all the points where the data is labeled as sell in red and hold in green. All the others that are not labeled are buy in green. All the others are labeled hold. So with that information, we can start over. We open up AIMS. If we go to data sets, you see I've renamed it like this, and now you can use it. I've tested a lot, and I found out, if you check this, when you have just installed MetaTrader 4 and you have no large amount of historical data, you can deactivate here the auto scrolling of the chart and can go back as far as possible. In this case, Admiral Markets is offering us, like, I would say 4 or 5 years of hourly data. If I scroll back, you see we will come to an end very soon. And yeah, we are here 26th April of 2018. Until here we got data from Admiral Markets. But I found out that is not enough. If you just use, like, these were like, I think 20,000 examples or 25,000, I'm not pretty sure, then you will end up with bad accuracies. You won't get higher than 20% or something, 40%, and that's not enough. So I decided to download again data from Dukascopy, and I will show you that. I've already mentioned Dukascopy in all of the older videos. You can, if you register here, you can use their website for historical data feed. And what I'm going to do right now is I will download 5-minute data from the Dow Jones Industrial Average. Let's check this out. America, USA 30. And now, like, okay, 5 minutes. I have to type in 5 again. Bit, okay. And anywhere here, there was an information that if you choose minute data, it's just allowed to choose like the last 3 years. That means we go back 3 years, and do it like that. For example, filters. You can activate filters like without weekends, without overnight time, and so on. Okay, activate everything and download. Then you have to log in and you can pull the data as hist file. If you have done that, you can go here to Admiral Markets, go to Extras, History Database, and then you can already see I've imported it into the 5-minute chart. We got like 209,000 entries. You have to go to Import, then this window pops up. That hist file is to be found, and you can go to like where have you saved it, and click it, click OK. Everything is imported, and if you then choose, for example, this one, and click on 5 minutes, you can scroll back like hell. You have seen already, I have not chosen some filters. Oh no, it seems like I've chosen filters when I used it. That means no weekends, no overnight flatliners, everything is filtered, and I could scroll back like 3 years. Okay, so we will use this data because it's a lot. I have already imported it and I have chosen, let's have a look. This is what I've chosen, the 5-minute chart. Rise 100 points or fall 100 points is the max win pips, right? Let's see it again in Admiral Markets. Send to AI UI. Let's say 100. Okay, I will recreate this again. 30, 20, 20. Then I have renamed it in Jones Industrial 5 minutes. That we know the time frame in the end. 100, 30, 20. And the time frame is 3 years from now in the back. These indicators, and hit OK, and then you will see in the journal like it will take 5 minutes to send all the data. You can also choose different markets for sure. I have chosen this one, just because I did it. So what are we doing now? We have to create a new project. Let's start over. I will call it Dow Jones Industrial Trading. Okay, and we will start creating an AI that is capable of trading this data. We will choose the data set we have talked about. You can see we have like 204,324 examples with 9 columns. And as usual, we have to drop some columns in the first place. What are we going to drop? We will drop the first one. This is a timestamp. In this version of Ames, you will not be able to use this, but in future versions, there will be a way to use these, but not right now. After we have created the new data set, because we lost one column, I will show you the distribution of the labels. That's most important, because we want to know in how many cases there has been an action for buy, sell or hold. The action column is called Handlung. Handlung is the German word for action. We have programmed it that way because we are from Germany. I hope that's okay for you so far to understand and use it. You can rename it if you want to, no problem. So you can see from this 204,000 examples, we got like 164,000 hold scenarios, around about 19,000 for buy and 21,000 for sell. Usually in the last 10 or 20 years we had more buy scenarios than sell scenarios. Sure, because the market was rising all the time, but because of Corona, I'm pretty sure that's the reason, we got more sell scenarios in the last 3 years. So that's the case, but hopefully it will not influence the performance of the algorithm. So first of all, what we're doing here is we will have to encode data. Encoding means we will have to change the way this last column is represented. We call it encode action. Okay. We will hot encode the actions. I have already talked about this in other videos. That means we take this column, it's label encoded, 0 for hold, 1 for buy, 2 for sell, and now we take this column and create out of this column 3 columns. That means hold means 1, 0, 0, buy means 0, 1, 0, and sell means 0, 0, 1. Just live with it. If you got questions about it, there are several sources on the internet that explain that. It's just state-of-the-art procedure to create AI, to create machine learning algorithms that use encoded variables or classification variables, because we are doing a classification here, right? So let's go on with a scaling. Why scaling? Okay, I will have to use a box plot first to explain this. We use this data and we will use all the columns, but we won't need the handlings columns, the action columns. I want to show you how the data is distributed, okay? Because that's important. As I have already talked about in other videos, usually a neural network that is trained on data learns things the most that have the most impact in the gradient. That means if you got 2 different examples, right, one time step to another, and you got one value that is really, really high, the gradient of this value from one time step to another can be huge. Regarding the other values, as you can see, RSI, day of week, whatever, volume is massively higher than all the other values. These may lie in between 0 and 1 or 0 and 100, and volume lies in between 0 and 600,000, whatever. So you can imagine that volume might have a bigger impact while training than all the other variables. We don't want that, because we are not considering that the volume has more impact than the RSI or gradient or close value, whatever. So we do scaling from the input variables. Dow Jones Industrial. Okay, so we scale in between 0 and 1. You can scale in between other values if you want to. Most important is that you scale the input data. Usually you can try to leave this out. You don't have to, but in my experience it helps the performance of the model very drastically, especially if the values are that high in the difference. So let's check again how the data set has changed. What is scaling doing? Well, it's going inside one column, finds out what is the highest value, what is the lowest value, and sets these to 0 and 1, and then rescales all the data values in between this range. So you see right now everything is in between 0 and 1, so that the algorithm can learn not just to focus on volume because it's that high, but also to consider all the other values as well. Now we have scaled, we have to do sequentialization. I have shown you what the time window means. Like here, I have made this presentation for you in the introduction video. You see we got a time window of 100 time steps, and we call this sequentialization. We also have a node for that. It's called sequentialize, right? You can also see this cute little clock inside the window. Yeah, it's really funny. Let's start over. Okay, we call it SIG DJI for Dow Jones Industrial. We give it 100 time steps, right? we have to hit reverse. That's because of MetaTrader 4 is sending the data in a reverse direction way. If you don't hit reverse, you will get really high accuracies, but your algorithm won't work in the end because it's wrong. Okay, just take it as it is. And the targets are these three values, right? Handlung 0, Handlung 1, and Handlung 2. So the actions. Shift targets means, okay, if I type in a 1, it will take the target columns from one step ahead, or 2 or 3 or 100 steps ahead, so you can try to predict the labels from the future, for example, for far more in the future, not only the next. Okay, so let's hit proceed. This might take a little time because sequentializing 100,000 or 200,000 values might take some time, because this table will end up from 204,000 rows and 10 columns to like 203,000 rows and 1,000 columns. Okay, because we got we got 10 columns, but we have to subtract the action columns, so we got left over 7, and 7 indicators, 7 features multiplied with 100 time steps means 700 columns. So we will end up with 703 columns because we add the action at the end again. So it took me like 2 minutes or 3 minutes to make this happen. Depends on your hardware. So as I have told you, we got like 703 columns now. Now we are done with the data transformations so far, and what we want to do now is also something I have forgotten in the beginning. I want to show you also the so-called correlation matrix. So we take the input data, I can put it above this, and we want to see also how the data is correlated. I will tell you why. We can take all of these. The correlation matrix is trying to find out if the variables, the features you are using, are highly correlated one to each other in one or another direction. Blue means if one value is rising, the other value is falling, and red means if one value is rising, another value is also rising. So therefore you got this line here, always red, because close is always directly correlated with close, and gradient also with gradient. So, and here you can see if there are any high correlations in between the values. We have pre-chosen the data in a way that it is not like that. If you would have imported open, high, low, close, for example, you would have seen that they are highly correlated because they are always near to each other. And why is that important? If you train artificial neural networks for deep learning, you don't want to use features that are highly correlated, redundant, because this leads to overfitting in the network. We don't want overfitting because that means the neural network is just learning what it has seen. It will not be able to generalize on the problem very good. So you don't want this to happen, and therefore you will have to filter out variables that you could say more than one times inside the data. If you got double or triple data representations from different variables, you don't want that. You want variables that are like they are, without dependencies to others. Okay, so looks good so far. Now we have to split the data set. We will just use a train val split, and we make it normal. We just use like 90% for training and 10% for testing. And we use the mode normal because we want the first 90% of this 3 years as training data, and the last 90%, the last 10% of this data for validation or for backtesting, whatever. So right now we split the data we want to use for training, 90%, and 10% we leave out to see if the algorithm is good in generalizing. Because if we don't split the data, we can train the algorithm to trade perfectly. It will learn everything it has seen, and it will be able to do the backtest with a huge amount of money that it has won. But it's false, because it will not be able then to predict on future stock market happenings, if you want to say so, because it just had learned what was happening in the past, but is not able to generalize. So therefore we have to split the data in a training data set as well as a validation data set, at least. You could also do a train val test split, but at least two, to see while you are training if your algorithm is overfitting, is still good in predicting the validation data that has not been trained on the AI, and then you find the right time to stop the training. Because it's always the question, okay, when does AI developer or whatever has to stop the training? And therefore you use different data sets and see it on the loss functions as well as the accuracies. We will come to this in just a few moments. So now what we also need are resampling nodes. We will resample the target data. Why? I will tell you just when I have activated everything. We will do it for the training as well as the validation data. Well, I've shown you, this will take some seconds, I've shown you distribution, right? If we train the distribution like that, the algorithm will learn, okay, if I say always 0 for hold, I'm like 70 or 80% of the time right. So that's the common case, and it's the best I can do. Therefore, we want to do some resampling that, we take these examples we got here and pack them inside the data set several times, so that with each training of the AI, with each training epoch, the AI is not just seeing like 80% of holding scenarios. It has to see like 33% of hold scenarios, 33% of buy scenarios, and 33% of sell scenarios. So it should be evenly distributed. It's like if you have seen in your whole life like 100,000 dogs, right? And just one cat. You might not be able to reconstruct a cat or know what the features of a cat are if you haven't seen a lot of them in comparison to the amount of dogs you have seen. So in this case, it's the same. We want the algorithm not to think, okay, there is just a hold scenario out there. Even if we have to admit that most of the cases should be hold, because you just want to enter the market when it's the right time and then take your profits, right? And that's not all the time, usually. So this will take some seconds. And I can show you already here, the validation data set had like 20,423 examples, and now it has like 50,000 because we random oversampled the data set, especially for buy and sell scenarios, because most of the scenarios are hold, and we filled it up with the data. So now that we've done, I always click in these previews, because then the overall work of the visualizations is more fluid, right? If you got more objects that has to be rendered, it will take some time. So now we can come to training, but first of all we will need to create an architecture, because now we have the data, right? And it's a data-centric programming, so we feed a neural network data and train it, but we will need to create a neural network. Let's go. So what do we need to extract? What we have to create in the neural network is we have to look at the amount of columns. We got like 700 input columns and 3 output columns. That's important because we got 700 inputs in the neural network, and as outcome we want to predict 3 different certainties for holding, buying and selling. So let's go and create an architecture. Let's call it like Dow Jones Industrial. We make it a dense net, 700 input values, 3 output values. So did you know later on, okay, that's what I have chosen. We start with a input node, minimize it, minimize the shape, and put in the value of 700. What I do now is usually I put another node called dense node, fully connected node, directly onto it with the exact amount of input values, 700. Let's check another activation function. Let's choose ELU. I've just googled it and found visualization for the ELU function. What has been there already was the ReLU function. ReLU means, okay, the input is below 0, it will become 0, and if it's above 0, it will be linearly the same value, if you would say so. ELU means we got some non-linearity, a stronger non-linearity in the region of minus infinity to 0. Like if the value of any input is below 0, it will be approximate by this function here, right? It can become like -1 in the end, depending on how far it, how deep it is below 0. Okay, it's just an activation function. You could also choose ZILU and SigmoIt, for example. ELU trains a lot faster, and therefore we choose this. Okay, so now in my experience, it helped a lot if you choose layer normalization. If you put in a layer normalization after each dense layer, close to each dense layer, this helps the training performance in speed as well as accuracy. Okay, if you want to know what it is, how it works, just check out some YouTube videos of other people. They made a lot of stuff about that. Really good stuff. So we will not discuss this here right now. So just get with it. And now I will try to go down step by step with the amount of nodes, because the neural network is built like, how to say, a funnel, right? Like a funnel where the nodes are getting fewer and fewer until you end up with the amount of output nodes you want to have, like in this case 3. We start with 700 and we go like, let's say 511. I usually like the prime numbers. If this is one, I can't really tell, but it's uneven in the end. Let's get deeper, like 321. ELU 3, and again a layer normalization, this, and dense again. Let's do ELU here, let's do 111. And now I would choose also a so-called dropout layer. That helps by generalizing, because you randomly drop out some node connections if you want so, like let's say 27%. We connect dense layer again, let's say, what did we have here, 111, let's take 31. ELU again, And then we got the last layer with 3 units. Here we have to choose softmax, because the softmax activation function is used for classification tasks. Now we make a beautiful layout nodes and save it. If you have done everything right, it will compile and you can go ahead. Let's get back to the project. And now we have to drag and drop an architecture node. I will show you in the next video some different architectures and how to train them, how to create them. Talk a little bit about the differences so that you can try to create different neural networks and try to make even better predictions. But I have to say, most of the cases, it's more important to have a look at the data than to have a look at the neural networks. Okay, so let's start with it. We have dragged and dropped training node 2. We give it a name like Dow Jones Industrial, 5 minutes. Yeah, and version 1. Okay, I think 100 might be enough. Epochs. 1 epoch means all of the data, like in this case here, 441,000 examples, because that's the train data set, will go through it 100 times. And each epoch, or each step at least, the neural network changes. We have to use categorical cross entropy because that's the loss function we use for classification tasks. I will use fallback train to CPU because that's the free version. You can just train on a CPU if you want to. If you want to train on a GPU or multi GPUs, you will have to buy this feature, but I'm pretty sure you will not need this in this scenario. Data options means, okay, how big is the batch size? So imagine you got 1 epoch with 400,000 examples, but you will never be able to put 400,000 examples into your memory usually, so you have to split it. Let's say we take like let's say 5,120. Okay, the targets. This is where we tell the algorithm, okay, what are we going to train for? Okay, we have to say, okay, these are the values it has to learn about. Metrics, we have to choose categorical accuracy, because if we don't choose this, we will just see the loss, but not how good the accuracy is in terms of percentages, certainties. And here we choose the ADAM optimizer with, like, let's say 4 zeros. Let's start with this and see how it goes. Okay, let's start. Now we can open up here the task manager and have a look. You will see as soon as the training really starts, here you will see some change. There will not be a none anymore, and as long as the training has not started, the RAM will rise because the data is now put into your memory. And because we have clicked on cache, we will accelerate the training even more if the first epoch is done. That means the algorithm will now store all the data in the random access memory to access it fast. And for each epoch, it will pull it out again from there and not from the HDD or from your normal space drive, whatever. And it's even faster. So the first epoch will take a little bit longer usually, and the other epochs will be faster then. So you see the training is starting. You can also see it in the CPU power. Yeah, and now we have to wait. So let's do it. Well, now we have come to a point, you can see it, where the training loss in orange is crossing the validation loss in red. What does the losses mean? So the training loss is the loss that comes from the data that runs through the AI from the training data set, and the calculated validation loss comes from the data that runs through the neural network, through the trained neural network each epoch from the validation data set. So you have also the values categorical accuracy and validation categorical accuracy. You see in the green line the validation categorical accuracy, where we got the last 10% of the data we have from the Dow Jones in 5-minute data, is around about 52% accurate. That means from all the cases that occur, 52% are predicted right. Random would be 33%, right? And 52 is therefore a lot better. You can see also that the categorical accuracy of the training data set is still below the validation accuracy, but you have to mention that there are a lot more examples inside, 10 times more examples, or 9 times. And we wait now for the moment where the categorical accuracy from the training data set and the validation categorical accuracy will kind of cross. Like the loss has crossed, we will end the training soon now. We will end up with like 50% in general accuracy, because at this point the algorithm seems to learn more about the past in learn by memorizing what happened and not anymore generalizing patterns. You know, it would just learn, okay, we had this value and this value in combination, so it has to be this case, and will not learn in general how to handle the features like, okay, if this value is round about that and this value is round about that, then we have a bias scenario. So we have to find out this point where the loss of the training data set and the validation data set are leaving their combination, getting out in their range, because this is the exact point where we stop the training and use the model for further investigation. So we are close to the end. We will stop the training after the 41st epoch. We have we want to focus a little bit more on the accuracy of the training data set in blue, because it represents more of the data than the green line. But you have to mention that's the data it has been trained on. So the ground truth is somewhere in between. After this epoch, we will stop it and use the algorithm to check out how well it performs. So let's stop. And you can always hit the continue training button, okay? And then training will go starting from 41st epoch and go ahead. Okay, now we want to see how well the algorithm performed. We will use a prediction node, and we will use the original data now. That means we will not use the resampled data, but we want to know what happened regarding the original data. The difference is, as I described, that the distribution of the data is in the original data set more hold-centric, and the less sell and buy scenarios are there to be found. But yeah, that's just the way it is. And the prediction node is just for predicting all the values, put it into a column, and afterwards we use the confusion matrix to visualize it. That means the confusion matrix will tell you how good is the algorithm regarding all the different classes. So we are done, and now we will have to combine these nodes and hit proceed, and you will see the result in form of a confusion matrix. Confusion matrix is the right word for this kind of visualization, but it's a good way of showing how well the algorithm performs. Some of you might know the confusion matrix from COVID. There we had like just two possible outcomes. So it was a 2x2 matrix. Now we got 3 outcomes, and it's a 3x3 matrix. Best way would be if this here would be completely filled and nothing all around. You got on the left side what is the real label, and on the downside what is the predicted label. Like here, Handlung 0, so hold, right? In 9,975 cases, it has been predicted right, but in like 2,343 cases, the algorithm told us it's a buy scenario, and 3,900 cases it told us it's a sell scenario, when it was actually a hold scenario, and also for the other cases. So you can see it. You know the exact value is around about 50%, and I will show you in the future how to combine different AI models you have trained on different patterns, and I mean with different patterns the data. Okay, we used like 100, 30, 20. You can use 80, 40, 10, whatever, and train 10 different AI models and combine them to maybe get even a better probability in the end. So that's it from now. I just want to show you, if you go to our website, hit AIMS and here AI Lab, you will be able to find all the data, not only in the YouTube description, I will link it there, but also here, if you scroll down, you will find time series forecast. This is the trading project I showing here. You can download everything you need, and yeah, that's it for so far. Thanks for your attention, and hopefully we see us in the next episode, where I am going to talk about different neural network architectures, how to set them up, how to train them, and so on. So have a nice day.